You know that feeling, right? You're in the middle of an intense game and your phone starts getting, well, hot, like really hot. That heat, it's the number one enemy of performance. So today we're going to tear down, figuratively of course, the new iPhone 17 Pro and look at the amazing tech Apple is using to finally win that fight. All right, so here's the plan. First, we'll talk about why this is even a problem. Then, we'll check out Apple's big new solution. We'll get into the nitty-gritty of how it actually works, see how it stacks up against older tech, and then, the most important part, what it all means for you. Okay, first things first. Before we can appreciate the solution, we've got to really get our heads around the problem. And with phones these days, it really all boils down to a battle between power and heat. So why do our powerful phones get so darn hot? We've all been there, right? You're gaming, maybe you're cutting a 4K video for social media, or just on a super long video call, and suddenly your phone feels more like a pocket radiator. What's actually going on there? Well, this one phrase I saw in a report pretty much nails it. It's this constant tug of war in smartphone design. We want more and more power, but we want it packed into phones that are thinner and lighter than ever. And that's a recipe for disaster. It's a total performance collision. We want these beefy desktop-level features, but we also want these super sleek designs. So what happens? You get a ton of heat crammed into a tiny little space. And the consequences are real. Your phone starts throttling, that's when it slows itself down just to avoid melting, your battery life tanks, and you can even risk damaging the hardware inside. All right, so that's the problem. It's a big one. Now, how is Apple tackling it? Let's dive into the actual cooling system they've packed into the iPhone 17 Pro. So Apple's approach is kind of like a 1-2 punch. It's part material science, part really clever engineering. First, you've got this unibody frame. It's made of a special aluminum that's really, really good at moving heat around. But then, and this is the cool part, they've built a custom laser-welded vapor chamber right into the phone's structure. And listen to how Apple talks about this. This isn't just some marketing buzzword. They're basically saying that this cooling system is the key that unlocks the phone's true power. Think about that. Without this specific piece of tech, that fancy new A19 Pro chip just couldn't do what it's designed to do. Okay, so vapor chambers. Apple is clearly all in on this tech. But what the heck is it? How does this little sealed box work its magic inside your phone? Let's get into the physics of it. Basically, a vapor chamber is just a super efficient way to spread heat out. Picture a super thin, hollow, sealed metal plate. Inside, there's a special wick-like material and just a tiny drop of liquid. That's it. The real secret sauce is how it uses a non-stop cycle of boiling and condensing to move heat. And here's how that cycle works, step by step. First, the liquid touches the hot processor and instantly boils, turning into vapor. This phase change sucks up a ton of heat energy. Second, that hot vapor expands and fills the entire chamber in a split second, spreading the heat out. Third, when the vapor hits the cooler outer walls of the chamber, it turns back into a liquid, releasing all that heat, which then gets absorbed by the phone's metal frame. And finally, that wick structure pulls the liquid right back to the processor to do it all over again. And this happens thousands of times every single second. It's wild. Now, you might be thinking, wait a minute, I've heard of heat pipes in my laptop or my PlayStation. Isn't this just a flat heat pipe? And you're not wrong, but you're not entirely right either. They use the same basic idea, but what they do and how well they do it, especially in a phone, is completely different. So here's the best way to think about it. A heat pipe is one-dimensional. It's like a heat highway. Its job is to move heat from one specific spot to another. A vapor chamber, on the other hand, is two-dimensional. It's more like a heat plaza or a public square. Its job isn't to move heat a long distance, but to take that super concentrated heat from the chip and spread it out evenly over a much bigger area. And that simple difference in shape leads to a mind-blowing difference in performance. Your average heat pipe can handle maybe 125 watts of heat. A vapor chamber, we're talking up to 450 watts. It's not even close. And that's why it's the perfect tool for dealing with the crazy powerful tiny chips we have in our phones today. Okay, so we've geeked out on the engineering and the physics, but let's get back to what really matters, the so what question. What does all this fancy tech actually mean for you when you're using your phone? Why should you even care about this stuff? Well, for starters, there's this huge number Apple is throwing around, a 40% improvement in sustained performance. And that word, sustained, is everything. It doesn't just mean the phone is faster for a second. It means it stays fast for a long time without hitting that thermal wall and slowing to a crawl.
And the reason it can do that is pretty simple. The chip is literally running cooler. We've seen studies that show a vapor chamber can drop the chip's temperature by 5 degrees Celsius compared to older cooling methods. Now, 5 degrees might not sound like a lot, but in the world of computer chips, that is a massive, massive difference.
So, how is that even possible? Well, there's a simple rule of thumb for this to be effective. The surface area of the vapor chamber has to be at least 10 times bigger than the chip itself. It all comes back to that plaza idea. You're taking all the heat from a tiny, super hot spot and giving it a massive area to spread out and cool down. So, at the end of the day, all this clever engineering just means a better phone for you. It means your games run smoother. It means multitasking doesn't bog down your phone. It even means your device might last longer because the parts inside aren't being cooked all the time. This is the secret sauce that lets companies build ridiculously powerful phones that are still super thin and don't have terrible battery life. And that really leaves us with one final question to think about. Vapor chambers are the solution for today. They're state of the art. But what about tomorrow? With on-device AI and even crazier games pushing things even further, what's next? Are we going to see tiny little fans inside our phones? Some other crazy solution? It's a huge challenge, and whoever solves it first will pretty much define the future of what our phones can do.